Hello dear students, welcome back to the Pharma Learning channel. Today I bring the one of the new another video on the unit operation, which is known as centrifugation. So in this video I will try to highlight what is the theory or the principle of the centrifugation is. So let's try to go into the details of the principle of the centrifugation. Before I start with this particular topic, for the tutoring or the coaching need of any of the subject or any of the topic related to either pharmaceutics or the pharmaceutical technology at the diploma level or the B.Pharm or at the master's level, please feel free to contact me on pharmalearning@gmail.com, or you can reach out to me on the WhatsApp number given in this slide. So now let's try to understand what is centrifugation and try to understand the principle of the centrifugation. So centrifugation is a unit operation. As you know, the unit operation only involves the physical change. Basically, it is used for the separation of two things. The first one, it is used for the separation of the insoluble solid from the liquid. So what is the meaning of this one? Let's say this is insoluble solids are suspended into a liquid will be there, and after the centrifugation what we are finding the liquid is going to remain on the top while the solids, insoluble solids, are going to be settled down. This operation, that is centrifugation, also used for the separation of two immiscible liquids mixtures will be there. As for example, let's say this is the liquid A and the B mixed together, and when we are going for the centrifugation, after that we are finding the liquid B and the liquid A are going to separate it depending upon their specific gravity or the density. The lighter liquid is going to remain on the top while the denser liquid is going to be remain on the bottom. So if you are going to mix oil and the water, so let's say this is an example of an emulsion and we are going for the centrifugation of the emulsion, then we are finding the oil. If the emulsion is oil in the water type, or the oil in water in oil type, whatever it may be, the oil is going to be remain on the top while the water is going to be remain at the bottom in the where the liquid B is there. This is entire either of the application is carried out by the use of the centrifugal force. Now what is the centrifugal force? Let's say, try to assume that this is a one center will be there and a car is rotating onto this circular path. So this is the force which will apply on that particular object. So try to understand that. Let's say the object is moving over here onto the circular path will be there. So this centrifugal force will try to pull out the object that is towards the periphery. So it is like a peripheral force will be there. So it will allow this car not to go into this same direction on the rotation, but it will allow it to go outside that's shown by this particular red arrow. Now let's try to go into the more details of the centrifugation principle. So let's try that is the center of an radial rotating path will be there. Here the object is shown by this particular circle. It is rotating on the circular path. So basically the object experiences two types of force will be there. The first one, that is called the centrifugal force, and to the centrifugal force will be try to pull out the object from that circular or the rotation part will be there. And the second type of the force, that is called the gravitational force, and the gravitational force is going downwards. But basically, whenever you are finding the separation of the insoluble solids, so the liquid is going to take place, it is nothing but it is due to the centrifugal effect, and the centrifugal effect C is basically the ratio of centrifugal force to the gravitational force. So we can say C is equal to F over G. As we know that the force is equal to mv square upon r, that's the m stands for the mass, v stands for the velocity, r stands for the radius of path, while you know that radius of force g is equal to m into g. M is equal to mass of the object and the g is equal to gravitational acceleration constant. So if we substitute this value into this equation, then we are going to get the equation into which we will cancel out the m, and then finally get the equation c is equal to v square upon gr. But as we are knowing that the velocity, when the object is rotating on the circular path, the velocity can be given by the equation 2 pi rn. Okay, so if we substitute this particular value to this one and try to simplify this particular equation, okay, by giving the value of the g as the greatest acceleration force. So in this case, we are finding the final equation will be c is equal to 2.013 n squared d, while the n represents the speed of rotation. So that is the revolution per minute. So if this is circular path fixed, so how many revolutions, how many rotations are going to be taking place per minute? That is called as a small n, and the d represents the diameter of the circular path will be there. So this was all about the principle of the centrifugation. Please like this video and subscribe to my pharma learning channel for the more upcoming videos on the various topics related to pharmacy. Thank you.